Now, due to the advent and rise of the coronavirus disease of 2019, most of the countries have gone under lockdown, and all of the corporate offices have adopted a work from home fashion of operations. Now, in such a scenario, what's coming extremely handy is cloud computing. What it does is basically it cuts down your cost on servers and your pay to maintain it, as well as making it easier to scale the process. Now, one of the market leaders for cloud computing is obviously Amazon. And one of the many powerful and extremely functional features that have come out of the Amazon Web Services is a chatbot. So today's session is going to be all about using AWS to create a fully functional chatbot. So before we begin, let's look at our agenda for today. So we're going to start out straight with the problem statement, followed by which we are going to talk a little bit about chatbots. Here we're going to discuss what exactly is a chatbot. We are also going to explore Amazon Lex, certain core terminologies when it comes to creating a chatbot, as well as the working and operation of Amazon Lex. Next, what we're going to do is we're going to talk about the AWS CloudFormation, and then the AWS CodePipeline, where we're going to discuss the working of the code pipeline. Finally, we are going to move on to our demo where we are going to be creating a .NET Core chatbot using Amazon Lex that lets you have a conversation with the chatbot about making orders online. The application architecture shall be using AWS Lambda, Amazon Lex, and Cognito to communicate with a .NET application deployed on an EC2 instance. With that, I come to the end of my agenda. Now, this is going to be a slightly more intermediate to advanced level session. So if you want a brush up of the basics, you can go ahead and check out our AWS playlist, the link to which will be there in the description box below. You can find all your basics regarding AWS, Lex, AWS Lambda, and EC2 instance in our YouTube playlist. Also, kindly take up this time to subscribe to us and don't forget to hit that bell icon to never miss an update from the Edureka YouTube channel. And if you want to learn more about AWS and all its features, do check out our certification training, the link to which also will be in the description bar. So without much ado, let's get started. Now, starting out, let's get straight into the problem statement. Our objective here is to create a chatbot using Amazon Lex. Now, chatbots are extremely common these days across all websites, especially service-based websites. They're usually there to provide customer support and answer frequently asked questions. Now, if we talk about frequently asked questions, 8 out of every 10 questions that are asked on certain sites are extremely common queries, are extremely common questions. So for questions like those, service-based site can definitely deploy a chatbot instead of having to employ humans to do the same job. Now, by saving so much of the human energy and time, they can actually apply that into making their service physically and functionally better, while the bots handle the more repetitive and mundane tasks. Now, a great example of this is a site like GoDaddy. Now, as soon as you go to their landing page, on the right, you will see a particular automated chat box, which is nothing but their chatbot. Here they have an automated message saying, "Let's go." And once you respond, there are certain fixed options that they obviously have pre-scripted responses for, like WordPress, SSL certification, emails, websites, creating domains. And if you click on something else, that's probably their cue to connect you to an actual human customer support. Hence, completely eliminating the necessity for human interaction and human time invested in a repetitive task like this. It's only when an exception occurs that you would actually need to involve an actual employee. And this entire system can be systemized and customized and save a lot of money for the company by using a chatbot. And this is applicable across the board in every vertical, in every domain. If you want to book flight tickets, hotel rooms, ask for services, order flowers, order food. Food ordering services are a very good example. Any delivery services are very good examples. If you place a query there, it just reduces the downtime of a response to deploy a chatbot instead of actual human customer support. So that is exactly what we are trying to achieve. So for creating a chatbot, we will be using something known as Amazon Lex, more about which we shall be learning later in this session. Through Lex, we can actually design our entire workflow, specify our intent. We can determine the flow of the conversation, how the conversation is going to proceed, and design everything that surrounds it. Try to make the chatbot as functional as we need it to be. You can put in audio inputs as well through Amazon Lex, and hence this is our choice of service. So first, we are going to determine everything regarding the conversation and frequently asked questions and the pre-scripting of the answers to those questions. And then we are going to have to plug in the conversation to Lambda and finally deploy this to any website or integrate it with our own website. So as a part of this project, your input is going to be a user trying to order flowers, and then that query is going to get passed on to the Amazon EC2 server, from which it's going to be passed on to Amazon Lex, which then sends it to the Lambda service for processing. Lambda is nothing but a serverless computing platform that we are going to be using, which is going to process our request. So instead of using it to deploy an entire server, what we're going to do is we're going to use the Lambda services to process serverless requests. And then we are going to send it over to the Amazon CloudWatch for monitoring. And once your request has been processed, it's going to be sent back to your Amazon Lex and finally intimating your end user. So this is what your entire architecture is going to look like. You're going to be using AWS Lambda, Amazon Lex, and Amazon Cognito to communicate with a .NET application, which is finally going to be deployed on an EC2 instance. Again, let me clarify. We are going to be creating a .NET Core chatbot using Amazon Lex. All right. And our objective here is to create a bot that basically lets your users have a conversation about ordering flowers online. The chatbot should ideally be responding to a series of inputs accurately on deploying this project. Yes? So I hope you guys are with me so far. So moving on, let's start out by understanding what exactly is a chatbot. All right. Now, chatbot is nothing but a computer program which is built to ideally establish a conversation where there is an input and output in natural language via speech or text by the end user. Your bot should basically understand the needs of the user or the basic intent of the user and send an appropriate response based on your organization's or business's policies. Now, a couple of facts. Chatbots basically cut out a lot of redundancy in a certain website, and they're often used as conversational agents that mimic written or spoken human speech for purposes of simulating an interaction with a real person. So there are two primary ways in which chatbots are offered to visitors. One is via web-based applications, and the second via standalone apps. In a more advanced deployment, a chatbot can potentially be powered by ML or machine learning to detect more complex conversational cadences. It's almost like giving them the power to think. Hence, they have garnered much popularity in the online shopping, ticket booking, and food ordering businesses. The first chatbot, Eliza, was built in 1966 to actually mimic human conversations. And it's one of the earliest examples of natural language processing computer programs that there is. Now, moving on, most of you might already know, but I'll still be putting this out. Now, the AWS Management Console has over 150 services. For example, there are services for computation, for learning, for storage, so on and so forth. There are many services available in AWS's arsenal, one of which is Amazon Lex, which is basically a service for building conversational interfaces into any application using voice and text. Now, when we talk about conversational systems integrated into an application, we are talking about systems which can easily interpret the input given to them. Now, this input can be either in speech or via text, right? It can be in both of these media, as we have discussed before. Now, examples of voice commands are many. We have Amazon's very own Alexa, we have Apple's Siri, we have Google's Google Home, and then we have examples from text commands, which will be any of your food apps like Swiggy and Zomato, your delivery apps like Dunzo, or the GoDaddy website, which I had shown previously. So there are a couple of ways through which we can give the command to our system, and then it's going to process that and give us our desired output. Now we need to understand in a language such as English, the meaning of certain words, certain phrases change along with the context. For example, if we take the word engaged, engaged could be a fiance getting engaged to his fiancée, or engaged could also be learners such as yourselves being very engaged in this presentation that I'm giving you, right? In two different contexts, the same word means two different things. Or take the word date, for example. A date can be a fruit, a date can be a time of the year, or a date can be a romantic outing with your friend or partner, right? So we need our bot to understand not just meanings of words, but also the context in which the words are used, so it can give us an appropriate answer. If I ask my chatbot, who is my date? And instead of giving a person's name, it gives me the current date of the particular day, then obviously we're doing something wrong, right? So the technology that is used for this is known as natural language processing. It's basically a subfield of information engineering and sometimes considered subfield of AI as well, which is concerned with the interactions between computers and human beings or natural languages, particularly how to program computers to process and analyze large amounts of natural language data. Now, apart from that, Chatbot also uses something known as ASR or automatic speech recognition. It's the technology that allows us as human users to use our voices to speak with a computer interface, such as a chatbot, in such a way that in its most sophisticated variations, it will most likely resemble a normal human conversation. It should be like you're talking to another human being. Like all of us have different ways in which we pronounce things. Since we all come from different geographies, we have different dialects. So whenever we are using speech as an input, we need our chatbot to understand our dialect. If you remember, when the first range of all these home assistant devices had come out, we had your Alexas and we had Google Home, including virtual assistants like Siri. All of these systems had trouble understanding the Indian accent. Most Indians could not use their virtual assistants because it just wouldn't understand certain dialects. But now, the newer models that have come up do understand way more dialects, including more common Indian accents, and are able to appropriately give us outputs that we require from them. However, a certain drawback, or you can't even say drawback, is just like a scope for improvement, is that even the most advanced NLP programs, despite the accuracy of roughly 96%, can only achieve certain results under ideal conditions in which the questions are directed at them by humans and are of a very simple fashion and limited number of possible response options based on selected keywords. Which is why most of these chatbots have predefined options of the most frequently asked queries, And if you choose the option which is different from the options they offer you, they direct you to an actual customer support person. Having said that, let's move on to the multiple components and core terminologies of Amazon Lex, which we are going to be using further in this session. So the first thing is Amazon Bot. Now, as we've discussed this, it is nothing but a program which simulates an interactive conversation, a human-like conversation. Yes, our objective is also that by the end of this session, we shall have created a fully functional deployable bot. Next, we have intent. Now, intent, as clear as its meaning, is what you want your bot to do. It is the purpose that your bot is intended to serve or perform. So let's take, for example, you are creating a bot for a food place. This is a very rudimentary example. So it's a pizza place which also serves sides. All right. So this is what your bot is going to look like. This is a pizza place. So first of all, I would want it to start with a greeting. So maybe, hi, how can I help you today? So then you can go ahead and type, I want to place an order, to which it would further ask the question, dine in, take away, or delivery, in which you specify maybe takeaway, which then is an information passed to your backend. And then you can go ahead and ask the question, what would you like to order? In which case they can just type in a name, suppose pizza, and then you would ask them what pizza, and then they would give in the name of the pizza. Let's keep it at that. So now through this user input, your backend team knows your order type as well as your order, which then can be processed immediately. All right. So this is how a basic chatbot should look like. It should ask all the important questions and then understand your language and context and go ahead and give you the appropriate response. So that was all about intent. Next, you have slot and slot types, which basically you can add as a part of your intent configuration. At runtime, your Amazon Lex is going to prompt you for a specific slot value. It's basically a type of configuration or parameter that your intent might need, which we will look into further once we start developing our bot. You can basically create built-in or custom slots, which are nothing but your slot types. With that, let's move on to intent fulfillment. So what is intent fulfillment? Remember just in the example that I was giving you, how I said once your user puts in their order and their order type, the information goes straight to your backend team. Now, the information definitely has to be processed before going into the backend team. So how do we do that? You either build a Lambda function to fulfill the intent, or you have a client application which does the necessary fulfillment for you. All right. And then you can define your Lambda function as code hook, where you can either customize your user interaction, initiate and validate your user input, or fulfill your user's intent. Now, one small thing I would like to touch up upon is the second part where you initiate and validate your user's input. Now, why validation is important? Basically, by creating a conversational chatbot, you're trying to cut down on the human involvement in more repetitive and mundane tasks and make the whole process a bit more efficient. Now, in such a case, some people would like to have fun with the bot. We all have done that at one given point in time. Let's all face it. So, suppose again going back to my food place chatbot example, if your chatbot asks, what would you like to order? And the user says masala dosa, and you don't have it in that menu, you will obviously not be able to serve it to them. So in such a case, you need to have a default option where your chatbot would reply with something such as, sorry, that's not a part of our menu, please try again, or something of that sort. Yes. So finally, we are at the part to see how basically this entire project is going to unfold and what are the steps that we need to follow to create this bot on top of Amazon Lex. So the typical steps that you're going to follow is starting out by creating a chatbot and configuring it with intents, slots, and utterances. We just discussed what are intents and slot types. Next, what we're going to do is we're going to go ahead, deploy the bot on a test window slide, which is provided in the console itself, and then publish a version of it. Now, while we publish a version of our bot, we're also going to be creating an alias, which is nothing but a pointer to your bot. What you'll further see is you can use this particular alias to allow your client applications to use a specific version of the bot without requiring to update your original bot. Then finally, you're going to go ahead and deploy your bot on the platform that you want to deploy it to or integrate it with your own website. Now, before moving ahead, let's go on and see how all of this looks like in actuality. So this is what our AWS Management Console looks like. Now here on the right, you can see I've chosen North Virginia. It's because the service we're going to use, Lex, is only available currently in select geographical locations. And one of them is North Virginia, and which is why I have selected that. Make sure you also go ahead and select one of the available locations. The others will most probably be grayed out once you navigate into the Lex service. So here on the service bar, I'm going to type Lex. I'm going to click on Amazon Lex, and this is going to lead us straight right here, where you can click on Get Started if you're using it for the first time. And just in case it's not your first time, it's going to lead you straight to the dashboard. But you can click on that, and then you have your Create Your Bot page. Here you can try a sample such as booking a trip or order flowers. Now, I know our objective is to create an order flowers sort of a chatbot, but we are not going to be using a sample. We are going to create one from scratch. So I'm going to click on Custom Bot, and here I'm going to name my bot Order Flowers. The language is going to remain English. And here you have a choice of output voices. So once you click on a voice, it will give you a little sample of what the voice sounds like. So this is Sally. We have a male voice such as Matthew. We have a Justin. We have a Kendra. We have a young female's voice called Ivy. So for me, I'm just going to keep it. So basically what you can do is you can customize it according to the need of your business. So I'm going to use Sally's voice. Now, when you make these selections, you actually can hear a sample of all the voices. Then I'm going to go ahead and put in a session timeout of 10 minutes. Now, you might have noticed if you haven't made any activity on a certain web page where you are using their chatbot for a couple of minutes, your session usually times out. So for my particular chatbot, I'm going to be keeping the session timeout as 10 minutes. Then you can go ahead and select the option of whether or not you want to perform sentiment analysis on your bot. Next, you have the IAM role, which in this case is predefined. It's basically an entity which defines a set of permissions for making AWS requests. You basically define the role of trusted entities such as users and applications, or services such as your EC2. Simply put, you can basically establish how one particular service interacts with another. And then we have the COPPA, which is the Children's Online Privacy Protection Act. So we're going to go ahead and select yes. So basically, we are contractually obligated to not ask any private questions to underage children through the medium of our conversational chatbots. Yes? So now we can go ahead and create. So now that we have our bot, we can go ahead and customize our bot according to our intent. Yes? So here below you can see the components of your bot. You have your intents, your utterances, your slots, your prompts, your fulfillment. You're going to have to specify a particular goal that you want to achieve through this bot, and then the medium in which you want your users to invoke your intent, how it must be processed, questions that are asked the user to input data, and finally some logic required to fulfill that particular intent. So we're going to go ahead and create intent. So here in the add intent dialog box that appears in front of you, we're going to go ahead and click on create intent. So we're going to call this order flowers and add. So here in the editors page, you can go ahead and enter your sample utterances, your Lambda initiation and validation, confirmation prompt, fulfillment, and response. So we're going to start out by adding utterances. These are basically what's inputs we think we are going to get from our users. So maybe I would like to order flowers or simply flowers. You can go ahead and add as many as you like. Some flowers, please. Okay. So next what I'm going to do is, this is nothing but the questions that you're going to ask in order to get information from your customer so that you can make your delivery. Yes. So we're going to start out by the city. There are a bunch of different predefined slot types, and our prompt is going to be, which city do you want the flowers to be delivered at? So which city is the delivery at? I'm going to add this. Next, I'm going to go ahead and ask the flower type, which is important. And my prompt is just going to be which flowers. So for flower type, I'm going to prompt which flowers do you need. But as you can see in the slot type, there are no built-in types for flowers. So what I'm going to do is I'm going to go to the left and create a custom slot type. So I'm going to click on this add button, create a slot type. Here I'm going to type flower types. Even in the description, I'm going to write flower types. And then I'm going to add a couple of values such as roses, lilies. What else? We have orchids. Carnations. I'm just going to go ahead and add a bunch of different flowers. You get the deal. Yeah. Okay, so that's all the flowers that I can think of. You can go ahead and add to your heart's content. I'm just going to go ahead and flower type. And here, as you can see, flower type is mentioned because we just added it to our intent. And then another important detail is which date do they want the delivery on. So we're going to click on that and we're going to add the prompt and add it. And then we're going to go ahead and make all of these questions mandatory for the user to answer, because without these, we do not have enough information to process the request. And I've also arranged the order in which I want the questions to be asked. So first I want the flower type to be asked, then the city, then the date. Yes? Then I'm going to go ahead and check the confirmation prompt, and I'm going to add in certain prompts for confirmation. And then we also need a prompt for canceling the order. So all right. So next what we are going to do is we're going to add in a response at the end of this order. So let's just keep it simple. Your order has been successfully placed. Now you can go ahead and add a little bit of customization, such as your order, or you can put in your slot type here. So when your customer, suppose, puts in an order for lilies, your response statement will come off as, "Thank you, your order for lilies has been successfully placed." Just going to go ahead and add that. I'm not going to enable a response card or anything. Now what we're going to do is we are going to save intent, and then we can go ahead and build upon it. So we can go ahead and test our bot. And as it says, you can continue editing your bot while the build is in process. We're just going to go ahead and build. Now this might take a minute, 5 minutes, maybe 10 minutes. These instances take time to load. Luckily for us, our build was successful and we immediately have our test bot right here in front of us. So let's go ahead and chat with our bot and see if it really works how it should. So here, as you can see, you can input via text or via voice. So what we're going to do, we're going to start out by testing out our input via text, and then we're going to go ahead and check the input via voice. So I'm going to start by a sample utterance. And I'm going to enter daisies. And as I enter my answers up here, you can see at the bottom, you can inspect your response. You can look at its summary and replies that are given by you. I'm putting in date. And with that, you can see our final messages here, even specified the kind of flower that I wanted to order. Now I'm going to clear this and try a voice clip. The console will prompt you if they can use your microphone. I'm just going to allow it. Flowers, please. Flowers, please. Daisies. Daisies. New York City. New York City. Now, clearly there's an issue in the case of an audio input, Now, that also may be due to my internet connectivity as well as my dialect, but at least it got some of the responses right. So I am kind of half impressed. With that, we come to the end of our first part of this session. Stay tuned for the next part where we are going to cover AWS CloudFormation as well as CodePipeline and complete the rest of this demonstration on the console. My name is Upasna. Thank you and have a great day.